Alright, this lesson is from section 4.3. The exercises start on page 309. But before we do that, I want us to look at this handout that I sent you by email. I hope you've had an opportunity to print it out. The lesson is about quadratic functions and their graphs. This is the basic function. You've heard me say before that if there's an x squared in the equation, that the graph is going to be a parabola. Well, this is what we call standard form, and this is what we call vertex form. And the vertex is either the bottom point or the top point of the parabola. And a parabola is always symmetric. It has a line that divides it through the middle that we call the axis of symmetry. And that axis of symmetry always goes through the vertex. So part of our quest is, if you're given the equation in this form, how do you find the vertex? Well, if you're given it in this form, it's easy. The vertex is just h and k. But if it's in this form, then we need to know how to find it. And there's a little formula right here that you find h by taking the opposite of b and dividing it by 2a. Now this is the a and this is the b. So you take the opposite of b and divide it by 2a. That gives you the value for h. Then when you have the value for h, you substitute it in for x into the equation, and the answer you get for y becomes the k part. So that's why this says that k is f of h, meaning if you plug in h into the equation, whatever you get, that becomes the k. Then I mentioned there was an axis of symmetry, and it is always the line, and because it's a line, it needs an equation, not just a number. So it's x equals h. Whatever that h was that you just computed, x equals that. Remember, x equals is a vertical line. That's the line that divides the parabola in half. Now, if a is greater than 0, meaning it's positive, and it's this a that we're talking about right here, these are the same a. If that's positive, then the parabola is going to open up. The vertex is going to be a minimum, meaning that it's the lowest point of the y values, the smallest y value, minimum, smallest y value. The minimum is the value k. It's the when we talk about the maximum or minimum of a function, we're always talking about the y values. So it'll be the k part of the vertex because that's the y part. We haven't mentioned decreasing and increasing before. I'm going to mention that briefly. Decreasing means as you move to left to right, the y values are getting smaller. And as you move, increasing then means as you move from left to right, the y values are getting larger. So when it opens up, it's decreasing from negative infinity to h. Oh, I didn't mention that. You talk about the y values when you want to know whether it's increasing or decreasing, but then you talk about the interval on which that happens. And all of these y values are decreasing. So we talk about the x interval, which is from out here at negative infinity all the way to h, whatever that h value is. And then it's increasing from that h value always to positive infinity. Now, those properties happen if a is positive. If a is negative, then the parabola is going to open down, and the vertex is going to be a maximum value. That means it's going to have the largest y value. Now the function is increasing from negative infinity to h, and it's decreasing from h to positive infinity. These are intervals on the x-axis that cause the y value to increase or decrease. Just like any other equations that we've been dealing with, if you want to find the x-intercept, you let y be 0 and solve for x. You may have to factor, you may have to use the quadratic formula, but you can solve for x. To find the y-intercept, you let x be 0 and solve for y, and you're going to see that when it's in this standard form, that's going to be a very easy process. All right, later in the session, we're going to talk about what if you're given the vertex and a point, how do you find the equation? Well, we start with the vertex form, and if you're given the vertex, then you know h and k, and you substitute those in there. You have a point, x and y, so you fill in the x and the y here and here. Now you've got everything filled in except the a. So that allows you to solve for a. Then you come back, you fill in the a you just found, the h that you were given, the k that you were given, and then fill it into that little formula. Then if it wants it in standard form, you simply square this binomial, multiply by a, and simplify. And we'll look at that in a little bit. The first group of problems we're going to look at are on page 309, and it's a matching activity. The first, number 15, you're given this equation. So a is 1 right here. Notice there's no x term, so that means b is 0 because it's ax squared plus bx plus c. We don't need c for what we're doing right now. So a is this invisible 1 and b is 0. So to find h, you take the opposite of b over 2 times a and you get 0. Now you take that 0 and put it back into this equation in order to find k. And I got negative 1. So that tells me my vertex is 0, negative 1. And because the a was a positive number, I know that this parabola is going to open up. So I look at my choices from a through h, and I see the one that has the vertex of 0, negative 1, and is opening up is C. So I'll match number 15 with letter C. Alright, I'm going to move on down to number 17, the same drill. A is this invisible 1, and B is now negative 2. Be sure you include the sign with it. Alright, the rule says to take the opposite of B. So the opposite of negative 2 becomes a positive 2. And 2 times 1, because it's 2A, is 2, so I get 1. Now, that's my H. So I take that 1 and put it back into this equation. That's what I've done right here to solve for K. So this vertex is 1, 0, and it's opening up. And I look at the choices that I have, and the one that has a vertex of 1, 0 and opens up is letter F. So I'll match number 17 with letter F. Okay. Moving on down, number 19, same drill. A is 1, B is negative 2. So again, H turns out to be 1. Put 1 into this equation. That's what I'm showing you right here. And I get 1. So this vertex is 1, 1. HK, 1, 1. Because the A is positive, it opens up. So the parabola that has a vertex at 1, 1 and is opening up is letter G. So I would match that one with G. All right, number 21. A is 1, B is negative 2. So the opposite of B becomes the opposite of negative 2, so that's a positive 2, over 2 times A, and that works out to be 1 again. Substitute 1 into here, and I get negative 1. So this vertex is 1, negative 1, and because this A is positive, this one's going to open up. So I'm looking for 1 with 1, negative 1, opening up. Which is right here at letter H. So I'll match that one with letter H. Okay? So that's how you can do a matching. You just find the vertex and decide which way it needs to open. And remember, we know which way it needs to open based on the value of A. If A is positive, it opens up. If A is negative, it opens down. All right. Now we're going to go on to this group of problems that's down here on the bottom. And you see this whole list of instructions. Well, the good news is your homework problems do not ask for all of this information in any one problem. It asks for parts of it. But we're going to go through it and do the whole thing because this is an excellent review from past stuff, because many of these things are things that we've looked at before. So we're going to start here, and just like we were just doing, we're going to identify that A in this case is negative 1 and B is negative 6. So H is going to be the opposite of B over 2 times A, or negative 3. To find K, I'm going to substitute negative 3 into this equation. Remember, you square before you take the opposite. So this is going to become a positive 9. Take the opposite, makes it a negative 9. And negative 6 times negative 3 is a positive 18. So when I add that together, I get a positive 9. So these two together tell me my vertex is negative 3, positive 9. Now, remember I told you back over here, we said that the axis of symmetry is just the line x equals h. So that's going to be x equals negative 3. That's a vertical line that's going to divide my parabola in half. Concave up or concave down just means, does it open up or does it open down? Well, my A is negative. Therefore, I know this one is going to be concave down. It's going to open down. All right, y-intercept. What I did was copied all these from all that was in the book, so we'd make it easier to follow. We've been doing y-intercept forever. How do you find it? You let x be 0 and solve for y. Well, 0 minus 0 is going to be 0. So if they want you to write it as an ordered pair, you write 0, 0. If they want you to write it as a number, then you just write 0. How do you find the x-intercept? You let y be 0 and solve for x. We can either factor or use the quadratic formula. This one will factor. We can factor out a negative x and get an x plus 6. Remember, when you factor, you let each factor equal 0. So I get x equals 0 because the opposite of 0 is still 0. I subtract 6 from both sides and get x equals negative 6. So my x-intercepts are the point 0, 0, which I already knew because it matches that one, and the point negative 6, 0. Okay? Then it tells me to graph the function. Most of the time, not always, but most of the time, having the vertex and your intercepts is enough to do it. There's a case where there's not, and we'll look at one of those in a minute. But in this case, if I go negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's my vertex, that's my top point. My x-intercepts and my y-intercept is 0, 0. And then I have another x-intercept, 1, 2, 3, 4, 5, 6, 0. My axis of symmetry is this line right here. So that line is dividing my parabola in half. So I can draw this. And you see how that axis of symmetry, that line x equals negative 3, divides the parabola in half. Okay? So that was this part C, graphing the function. Now, finding the domain. I don't think I wrote it on here, but let's make a note to that. I'll add it to yours before I send it to you. The domain is always all real numbers, because you see it takes up the x-axis all the way across. So the domain is always that. The range is going to change, but the domain's always that. So the domain is going to be all real numbers, negative infinity to positive infinity. Now the range. I tried to show you yesterday in the Zoom meeting that when we do range, we're talking about boxing in the y values. Well, this part just keeps on going forever. So there's no bottom down here. So that's going to be negative infinity. But there is a top point right here. The largest y value is 9. And remember, you go from bottom to top. So we'll do negative infinity to positive 9. That's going to be our range. And we'll use a bracket on 9 because it actually includes the 9. Alright, where is this increasing? Well, it's increasing to here until x is whatever this number is, which happens to be negative 3. And where is it decreasing? Right here. And even if you don't understand increasing and decreasing, you can copy it from this part right here. This one's open and down. So it's negative infinity to the h part, which was 3 for us, and then 3 to infinity. So that's a negative 3 rather. Not 3, but negative 3. That's how I got that. Alright, this last question is, where is f of x positive? That means, where are the y values positive? F of x, you remember, is just another name for y. So it's asking me where on the x-axis, or let me rephrase that. Where are the x values that make y positive? Well, y is positive anything above this line. So between where x is negative 6 to where x is 0, all of those y's are positive. So we'll write that as the open interval from negative 6 to 0. Well, where are they negative? All of this part and all of this part. But you do it as part of the x interval. So that's from negative infinity up to negative 6. That takes care of this part. And then from 0 over to positive infinity. Alright, so that's one complete problem. And like I told you, when you do the homework problems, they don't ask for all of this information in one problem. It asks for pieces of it. But in your book, it's all combined into one problem. So I wanted to do it that way. Now what I'm going to do is do several more just like this. If you understood this one and want to fast forward some, that's fine. But some of you will need to see the repetition, so I'm going to do several of them. Okay, here we go again. A is 1, B is 2. Excuse me. The opposite of B over 2 times A is -1. How do I find K? I take that value and put it into the equation. So that's 1 minus 2 minus 8. That's going to be a -9. So my vertex, putting those two pieces together, is the ordered pair -1, -9. The axis of symmetry is the line that divides it in half. It's always x equals h. And you need to remember, this is a time where you do need to put the x equals, because it does need to be the equation of a line. Alright, is it concave up or down? A is positive, so that tells me this one's going to open up. Y-intercept. Let x be 0, and you get -8. So it's the ordered pair, 0, -8, or if they want just a number, it's -8. X-intercept. Let y be 0, and I've told you that you can factor or use the quadratic formula. This one fortunately factors. So that's a good review for you. How do you factor a quadratic equation? When this number's 1, you find two numbers that can multiply to give you -8 and add to give you a +2, which is a +2 and a -4. And if you just wanted to factor it, you would stop there. But when you're actually solving an equation, you set each factor equal to 0 and solve for x. So I have two x-intercepts, -4, 0, and 2, 0. Now I'm going to graph my function. So my vertex is -1, -9. That's right there. My intercepts are -4, 1, 2, 3, 4, and +2. Now what you should see is that this line should be halfway between those x-intercepts. If it's not, then something's wrong, because this line, this axis of symmetry, has to divide this parabola in half. So it looks like that. Domain, we have said, it's always going to be all real numbers. The range. Well, this time, there's no way to box it in at the top. It keeps going forever, but it does have a starting point at the bottom, and that starting point is the y value of -9. So my y values, that's what your range is, your y values, go from -9 up to infinity. Where is it increasing? From -9 to positive infinity. And where is it decreasing? This part of the x-axis, which is negative infinity up to -9. Where are the y values positive? Well, they're positive here and here. What causes that? What are the x values that cause the y to be there? The x values from negative infinity up to negative 4, and from positive 2 to the right. Where are the y values negative? That's this little part, and that's between the x values between negative 4 and positive 2. When you're doing this, you're saying these are the x values that make y positive. These are the x values that make y negative. That's what that question's answering. Alright, moving on to number 47. A is 1, B is 2. A and B. H is the opposite of B divided by 2A, which is negative 1. K, I'm going to substitute negative 1 into the equation. So that's 1 minus 2 plus 1, which is going to be 0. So my vertex is going to be negative 1, 0. My axis of symmetry is x equals h. My A is positive, so it's going to open up. My y-intercept, I let y be 0, let x be 0 and solve for y. And you'll see what's happening every time when it looks like this. This is going to be your y-intercept, because this is going to be 0, this is going to be 0. So that's going to be your y-intercept. So that's the point 0, 1. To find the x-intercept, I let y be 0 and solve for x. Factors so that I can multiply to get 1 and combine to get 2 are 1 and 1. Set each one equal to 0. And I get x equals negative 1. I'm going to get the same thing there. So that's the point negative 1, 0. So this one only has one x-intercept. Notice this. The x-intercept is the same as the parabola. It's same as the vertex. That's the only way it can have only one, is if the x-intercept and the vertex are the same thing, then it's going to only have one. So this one I'm going to have to be a little more creative about how I graph it, because when I graph that vertex and my x-intercept only have 1 point, I can add my y-intercept to it, but I still don't have another point. Now remember, the line x equals negative 1 is my axis of symmetry. This line divides it in half. This point is 1 away from that line, so I can put its matching point right there. So that's one thing that the line of symmetry does, is allows me to match points. So now I can create my graph. My domain, you already know. My range. The lowest y value is 0, and it goes up from there. So that's 0 to infinity. It's increasing on this part of the x-axis. So that's from negative 1 to positive infinity. It's decreasing on this part of the x-axis. So that's from negative infinity to negative 1. Where are the y values positive? Everywhere except at 0. So we can put, but we got to leave out 0. So we'll do negative infinity to 0 combined with 0 to infinity. And that leaves the 0 out. And where is it negative? There are no negative values. So that'll be a none. All right, number 51. A is 2, B is negative 1. H is the opposite of B over 2A, which is 1/4. K is 2 times 1/4 squared minus 1/4 plus 2. That's 2 times 1 over 16 plus 1 over, minus, that's a minus sign, 1 over 4 plus 2. That's 1 over 8 minus 1 over 4 plus 2, which is 1 over 8 minus 2 over 8 plus 16 over 8, which is 15 over 8. Now, I just did it by getting a common denominator. You certainly could use your calculator to do this and not have to get a common denominator. Remember how to do that? Where's my calculator? Alright, let's remind people how we're going to use that. Let's see if y'all can see my calculator. You could even start back up here. We could go 2 times, and we could do 1 fraction 4 and square it, hit the x squared, minus 1 fraction 4, remember that's your fraction key, plus 2. You're going to get a mixed number, 1 7/8. So to turn it into an improper fraction, you do the second function and your fraction key and hit equals, and that's how you get the 15/8. So you could have easily done that with your calculator. Alright, so if I put those two pieces together, then my vertex is 1/4 and 15 over 8. Okay? So, my axis of symmetry, I'm going to write it right here, x equals whatever I got for h, so that's 1/4. My a was positive, so it's going to open up. My y-intercept, remember I just told you that it's going to be this number, because look what happens. 2 times 0 squared minus 0 plus 2, you're going to get 2. So that's your y-intercept. For your x-intercept, you're going to let y be 0. And you would try to factor that if you could, but it won't factor. So what I'm going to do is use the quadratic formula, and I don't have enough room on this paper, so I'll switch to over here. A is 2, B is negative 1, and C is 2. The quadratic formula says the opposite of B plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Now, I've encouraged you to use your calculator for this. So I'm going to do that. I'm going to put parentheses, negative 1, parentheses, squared, x squared, minus 4 times 2 times 2. And when I do that, I get a negative 15. Well, we don't know how to take the square root of a negative number within the real number system. We would have to use the complex number system, and you can't put that on a graph. So what that means is, since that doesn't exist, it means back over here, there is no x-intercept. Okay? Well, what do we know? We have this fraction, 1/4, which is about right there, and that's almost 2, so I'm going to put it about right there. Y'all see that? And then I have this point, 0, 2. That's my y-intercept. And this one opens up. Remember we said that. So if I match that point right there, see how I'm matching that distance? That's 3 little points. Now, if I were really doing this, I would find me another value. I would let x be, say, 2. I'm substituting in the equation. 2 squared is 4 times 2 is 8. So I'm going to get 8. So I have the point 2. 1, 2, 3, 4, 5, 6, 7, 8. So that gives me another point. Then I might let x be, say, negative 2. That's going to be 4 times 2 is 8, plus 2 is 12. So at negative 2, it's 10, 11, 12. So if I put all of that together, I get that graph. So my point is this. If your points are too close together, or if you don't want to deal with the fraction business, just find you some other values. Remember, it's just like making a table of values, letting x be 2, substituting it in, and finding the y to go with it. And I just randomly chose those 2 points. It didn't have to be 2 and negative 2. That's just points I used. It could have been 1 and negative 1, whatever. You could have used them. All right, you already know the answer for the domain. The range. You see this bottom value right here. Well, what was that y value? It was this y coordinate right here. So it's going to go from 15/8 all the way up to infinity. That's my range. Where is it increasing? This is my increasing part, and I do it as part of the x-axis. So that's from 1/4 to infinity. Where is it decreasing? I do the x-axis part, negative infinity to 1/4. Where is y positive? Well, all of these y values are positive, so that's everything. And where is it negative? Never. For this one. All right. How many more do I have? 2 more? Okay. Maybe we'll just do 1 more. I think y'all are probably getting tired of this by now. H. Oops. Opposite of B over 2A (1/2). Okay, remind you that you can do this arithmetic on your calculator. So I'm going to do it that way to model that. So we've got a negative 2. We're going to multiply that with the parenthesis, 1 fraction 2, parenthesis, and then hit the squared button, plus 2 times, and I'd probably put a parenthesis there too, 1 fraction 2 minus 3 equals. You get negative 2.5, and so I'm going to change that to an improper fraction using second and my fraction key, and I get negative 5/2. Negative 5/2. So my vertex is 1/2, negative 5/2. My axis of symmetry, x equals h. A is negative, so it's opening down. A y-intercept, we've said it before, this is 0, this is 0, it's going to be negative 3. So that's the point 0, negative 3. The x-intercept, I have to solve this equation. I don't know why I put parentheses there. And again, it won't factor. So I come back over here so I can do my quadratic formula. A is going to be negative 2, B is going to be positive 2, and C is going to be negative 3. Excellent practice for quadratic formula because several of you missed that on the midterm. So, the opposite of B, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Do this part, no radical, just do the part that's underneath it. So I'm going to do 2 squared minus 4 times negative 2 times negative 3, and I get a negative 20. Is that right? Yes, negative 20. So it's going to be the same scenario. Because this number's negative, it means I'm not going to have any x-intercepts. Okay? So I'm going to graph the point 1/2, negative 2.5. That's right there. I'm going to graph the point 0, negative 3. That's right there. I can match that point there. I know this one's open and down. Remember? I could do more points like I did last time, or I could just draw it in like that. Alright. I did the graph. Domain, we've said that a million times. The range. Negative infinity up to whatever that y value is. And that y value is negative 5/2. Then where is it increasing from negative infinity to 1/2? Where is it decreasing from 1/2 to positive infinity? Where are the y values positive? Look, no positive y values. Where are the y values negative? Everywhere. Okay? Now, I'm not going to do the last problem, but the only thing that's different about it is that when you do the quadratic formula to find the x-intercepts, it actually gives you a number. And so what you would do, I don't think there's any I like this on the homework, but what you would do is you should use the decimal value to know where to put it on the graph. If you run into one like that, let me know and I can help you with that. Alright, the last part, whoops, that's not a clean sheet. The last part of this lesson is the part about finding the equation. So I'm looking at problem number 61 on that same page. And I'm given a vertex of negative 3, 5, and I've given a point of 0, negative 4. Alright, so vertex is negative 3, 5, and I have a point of 0, negative 4. So this is H, K, X, Y. And on that handout, I told you to fill in all of those and solve for A. So that's what I'm going to do. You start out like this. Y equals A times X minus H squared plus K. The H is negative 3. X minus a negative 3. Okay? That's going to become a plus 3. I'm also going to fill in the x value. So that's going to become 0 plus 3. The x was 0, and it's minus h, so it's minus a negative 3. I don't know a. I know y is negative 4, and I know k is 5. So the only unknown I have in here is a, and that allows me to solve for a. 0 plus 3 is 3, squared is 9. And we would typically write that, instead of a times 9, we would typically write it as 9 times a. We put the numerical coefficient first. So now I just have an equation that I need to solve for a. So I'm going to subtract the 5. Then I'm going to divide by 9. And my a is negative 1. Now, you come back to this. And I showed you on the handout, you're going to fill in a, h, k. You're going to keep x and y as x and y. So I just found out that a was negative 1. Keep x. H is negative 3, so minus a negative 3 plus k. Fill in the a, the h, and the k. Alright, we don't usually write a 1, we just usually write a negative. And if it says you can relieve your answer in vertex form, then that's good. If it says you need to write your answer in standard form, then you need to come off to the side and figure out what x plus 3 squared is. X times x, x times 3, 3 times x, 3 times 3, now I need to distribute whatever the a value is. And look for any like terms I can combine, which are these two. And that's my answer in standard form. So this is my answer in vertex form. And this is my answer in standard form, depending on which way they might ask you for it. Okay, we're going to do another one like this one. We're going to do number 63 on the next page, 310. This time we have negative 1, 3, and 3, 5. So my vertex is negative 1, no, that's wrong. 1, negative 3. And the point is 3, 5. Okay, I'm doing number 63. So it's 1, negative 3, and 3, 5. This is h, this is k, this is x, this is y. Y equals a times x minus h squared plus k. Fill in everything except the a. Y is 5. X is 3. H is 1, so that's going to be minus 1 because it's minus h. K is negative 3. 3 minus 1 is 2, and 2 squared is 4. Change that around to be 4a. Then add 3 to both sides. Okay, so now a is 2. Y equals a times x minus h squared plus k. You're going to put the numbers in where I have these boxes. Only the a, the h, and the k. The x and the y will stay x and y. So y equals a, which is 2, times x minus h squared plus k. So that's just going to be minus 3. That's my answer in vertex form. If they want it in standard, then I have to square x minus 1. So I do x minus 1 times x minus 1, and this is what I'll get. I distribute that 2. And combine these like terms. And there's my answer in standard form. Alright, we have a couple of more problems to look at. These two right here. And let's look at what the directions are. Determine without graphing whether the given quadratic function has a maximum or a minimum, and then find the value. Well, the maximum or minimum is based on whether it opens up or down. So, number 67, because this is positive, it's going to open up. When it opens up, the vertex is a minimum value. The minimum value is whatever the k part of the vertex is. So to find k, I have to first find h. H is the opposite of b over 2 times a. Then to find k, 2 times negative 3 squared plus 12 times negative 3. I'm just putting that negative 3 into this equation. 9 times 2 is 18 minus 36. So k is negative 21. So the two questions were, does it have a maximum or minimum? And my answer is it has a minimum. And what is that minimum value? And my answer is negative 21. That's all that question asks us to do. Alright, let's go to number, there was one more, 71 we were going to do. Alright, a is negative, therefore it opens down and it has a maximum. The maximum value is still k. The answer is going to be k, it's just whether it's a maximum or a minimum. So because it opens down, this one has a maximum. And to find it, I do h is the opposite of b over 2a. Opposite of b over 2a. I get 2. K is negative 5 times 2 squared plus 20 times 2 plus 3. So I substitute h in here to solve for k. 4 times negative 5, 43. So my answers are, it has a maximum, and the maximum value is 23. And that's the end of this. Apologize that it was long, but there was a lot of stuff to do there. So hopefully you've survived through it and made it all the way to the end.